Alright, we're going to read through a security developer's guide on Oracle's website, get a sense of what Oracle thinks of Java security. It reads, Java security includes a large set of APIs, tools, and implementations of commonly used security algorithms, mechanisms, and protocols. Let's make this bigger for you guys to read. And sentences like this are kind of tough. I mean, you got a list of 3 items here, and then you have a list of 3 items here. So I wrote those 3 down, but I don't think they're very helpful. We'll see. The Java security APIs span a wide range of areas, including cryptography, PKI, secure communication, authentication, and access control. Java security technology provides the developer with a comprehensive security framework for writing applications and also provides the user or administrator with a set of tools to securely manage applications. So your typical introduction paragraph, nothing specific there. The JDK is designed with a strong emphasis on security. At its core, the Java language itself is type-safe and provides automatic garbage collection, enhancing the robust... Okay, so there's a marketing thing for Java. So type-safe automatic GC is our note. A secure class loading and verification mechanism ensures that only legitimate Java code is executed. The Java security architecture includes a large set of application programming interfaces to... Okay, they're repeating themselves. Jeez. The Java security APIs span a wide range of areas. Okay, the part that doesn't repeat itself starts here. Interfaces for performing authentication and access control enable applications to guard against unauthorized access. The APIs follow multiple interoperable implementations of algorithms and other security services. Services are implemented in providers, which are plugged into the JDK through a standard interface that makes it easy for applications to obtain security services without having to know anything about their implementations. So first question and answer. How are services implemented? They're as providers, so there's some terminology to wrap your mind around. Apparently this thing is plugged into a JDK. This allows developers to focus on how to integrate security into their applications rather than on how to actually implement complex security mechanisms. The JDK includes a number of providers that implement a core set of security services. Just in case you don't know what JDK stands for, that's Java Developers Kit. I like this picture the most when wrapping my mind around what the JDK is, but if you Google image that, it might be worth your time. The JDK also allows for additional custom providers to be installed, and this enables developers to extend the platform with new security mechanisms. The JDK is divided into modules. Modules that contain security APIs include the following. So we got table 1 here. First module, java.base, defines the foundational APIs of Java, SE, which stands for Standard Edition. Contained packages include Java Security, Java Crypto, .NET, .SSL, and .security.auth. Another module would be security.jgss. This defines the Java binding of the IETF Generic Security Services API. This module also contains GSS API mechanisms, including Cerberus, V5, and Spinago. So I don't know what that is. The next module is Smart Cardio. I'm a runner. I like cardio. Oh, but this is Smart Card Input Outputs. Never mind. Next one is XML Crypto. That's pretty self-explanatory. Then we got JDK.jar tool for signing jar files. Security.auth provides implementations of the java.security.auth .anything interfaces and various authentication modules. And the last one defines Java extensions to the GSS API and an implementation of the SASL GSS API mechanism. I'm just going to add that to my last question. Never heard of SASL. Now we're on the section Java Language Security and Bytecode Verification. The Java language is designed to be a type-safe and easy to use. It provides automatic memory management, GC, and range checking on the arrays, or on arrays. This reduces the overall programming burden placed on developers, leading to fewer subtle programming errors and to safer, more robust code. More marketing, but at least it gives us some specifics. So the question could be like, how is Java designed to be safe? Plenty of other languages do this as well, so let's move on. A compiler translates Java programs into a machine-independent bytecode representation. A bytecode verifier is invoked to ensure that only legitimate bytecodes are executed in the Java runtime. It checks that the bytecodes conform to the Java language specification and do not violate Java language rules or namespace restrictions. The verifier also checks for memory management violations, stack underflows or overflows, and illegal data typecasts. Once bytecodes have been verified, the Java runtime prepares them for execution. So the question is, what is the bytecode verifier checking? There's my answer, as short as possible. I almost just stopped with that first part, but the second sentence might be helpful as well. Essentially, once the verification is over, bytecodes are prepared for execution. Now, in addition, the Java language defines access modifiers that can be assigned to Java classes, methods, and fields, enabling developers to restrict access to their class implementations as appropriate. The language defines 4 distinct access levels. Okay, and this is probably no surprise to many coders out there, but here we go. Private is the most restrictive modifier. Access is not allowed outside the particular class in which the private member, a method for example, is defined. And let's create a question on that. What 4 access levels exist in Java? We got private, protected, public, and package private. Protected means there's access to any subclass or to other classes within the same package. So we're at the class level protection over here, then the package level, then package private. If not specified, then this is the default access level. Allows access to classes within the same package. Okay, and that's different than this one because this one allows access to any subclass, I think. And you know what I'm going to do? I'm going to put that question here. What's the difference between protected and package private? And then I'm going to do a note to self, check stack overflow for that answer. Our last one is public. No longer guarantees that the element is accessible everywhere. Accessibility depends upon whether the package containing that element is exported by its defining module and whether that module is readable by the module containing the code that is attempting to access it. And for a section like this, it's really just best to look at some code, so maybe we'll do that later. Our next section here, and let's say we'll just finish this and stop at security providers for the first video in this series. To wrap up, the JDK defines a set of APIs spanning major security areas, including cryptography, public key infrastructure, authentication, secure communication, and access control. The APIs allow developers to easily integrate security into their application code. And the good stuff begins below this line. So the first principle governing these APIs is implementation independence. II is what I'm going to call it. Applications do not need to implement security themselves. Rather, they can request security services from the JDK. Security services are implemented in providers. And what are providers again? We can go back to our notes. They're just services. So these services are plugged into the JDK via a standard interface. An application may rely on multiple independent providers for security functionality. And I think they have a typo here because then there's a space between implementation interoperability and the paragraph that belongs to it. But let's focus. What was the first thing? Implementation independence. I'm summarizing by saying providers provide security, not the application made by the developer. I think that's the big point right there. Then we have II2 coming up. It says implementation, interoperability. Providers are interoperable across applications. Specifically, an application is not bound to a specific provider, if it does not rely on default values from the provider. So I'm not sure how else to summarize this except saying it is interoperable. I think that's just meaning services can be used on any apps. The next one is algorithm extensibility. The JDK includes a number of built-in providers that implement a basic set of security services that are widely used today. However, some applications may rely on emerging standards not yet implemented or on proprietary services. The JDK supports the installation of custom providers that implement such services. Alright, now it's going to get into security providers, and I'll save that for the next video. Thanks for watching.